NASA's flying astronauts with a broken heat shield. Chunks the size of golf balls broke off Artemis 1. Instead of fixing it, they just tweaked the formula. Meanwhile, Elon Musk proved there's a safer way, and NASA knows it works because they forced SpaceX to use it. So why won't NASA apply SpaceX's solution to save their own astronauts? Let me walk you through exactly what happened during Artemis 1's reentry, because the details NASA glossed over are absolutely critical. When Orion came screaming back through Earth's atmosphere, the heat shield didn't just get hot. Gases built up underneath the avcoat material layer because the heating rate was slower than expected during the skip reentry profile. That trapped gas had nowhere to go, so it did what physics demanded. It blew chunks of the heat shield clean off the spacecraft. We're talking pieces the size of golf balls breaking away at thousands of degrees. Here's the part that should terrify you. NASA's ground tests completely missed this problem. Why? Because they used higher heat levels in their simulations. They tested for the wrong scenario, got false confidence, and only discovered the real issue after the spacecraft was already flying. That's not a minor oversight. That's a fundamental failure in testing methodology. So what did NASA do when they found cracking and chipping in the heat shield after Artemis 1 landed? They didn't redesign it. They didn't go back to the drawing board. They adjusted the material formula slightly and changed the re-entry flight path to reduce peak heating. Then they declared it ready for Artemis 2 with human beings on board. Does that sound like prove it's safe, or does that sound like we're running out of time and budget? Let's put this in perspective. Orion has been in development since 2005. That's 19 years. The total cost? Around $24 billion in nominal dollars, or $31 billion when you adjust for inflation. Nearly 2 decades and enough money to fund a small country's entire space program. And they still can't get the heat shield right. The version that flew on Artemis, one didn't even have a working life support system yet. It was basically an expensive test dummy, proving that, yes, the thing can survive re-entry if you don't mind losing chunks of it along the way. But the heat shield isn't the only corner NASA cut. Remember that faulty power and data unit I mentioned? During Artemis 1 preparations, engineers identified that one of Orion's 8 power units had a known defect. Replacing it would have delayed the mission by about a year. So NASA made a calculated gamble. They flew with the broken part anyway. The logic? Well, we have 7 other units. What are the odds this specific one fails at the exact wrong moment? That's the kind of reasoning that gets people killed in this industry. What happens if you're on your way to the moon and that faulty unit takes out critical systems? There's no AAA roadside assistance in deep space. You can't just pull over and wait for a tow truck. Once you leave Earth orbit, you're committed to the trajectory until you complete the mission or die trying. Safety experts have a term for what's happening at NASA right now. Normalization of deviance. It's when you start bending the rules just a little bit, and nothing bad happens, so you bend them a little more. Each small violation of protocol feels normal because the last one didn't cause a disaster. You keep pushing the boundaries of acceptable risk until one day the luck runs out and people die. NASA has lived through this nightmare before. The Challenger disaster. Engineers warned leadership that the O-rings wouldn't seal properly in cold temperatures. Leadership said it'll be fine, and launched anyway. 7 astronauts dead, 73 seconds after liftoff. Columbia. Foam debris hitting the wing during launch was treated as a known issue, an acceptable risk. It'll be fine. 7 more astronauts dead during re-entry when superheated gas burned through the damaged wing. The problem in both cases wasn't a lack of technical knowledge. NASA had brilliant engineers who understood exactly what could go wrong. The problem was institutional pressure to stay on schedule, overriding strict adherence to safety protocols. Sound familiar? Last year's Boeing Starliner incident showed the exact same warning signs, and this is where it gets really disturbing. According to NASA's own safety panel, both Boeing and NASA switched from an approve it's safe approach to an approve it's unsafe approach. Let me explain why that shift is absolutely catastrophic. Normally, NASA assumes every spacecraft is a death trap until rigorous testing proves otherwise. You have to demonstrate that every single system, heat shields, docking ports, thrusters, life support, works flawlessly under the worst possible conditions. The burden of proof is on showing it's safe. But somewhere along the line, that flipped. Now, NASA seems to be accepting flights unless someone can definitively prove they're deadly. That's backwards. That's how you end up with dead astronauts. During pre-flight testing for Starliner, both NASA and Boeing admitted they didn't fully understand why some thrusters failed or whether they'd work correctly on the next firing. They had data showing erratic behavior, they had unexplained failures, and they launched anyway. When Starliner had problems approaching the ISS, what did NASA do? They delayed issuing an official statement. They released vague updates that left everyone guessing what actually happened. If there was any doubt at all, that Starliner could safely return the crew to Earth, that should have been declared an emergency immediately. Transparency matters in aerospace because it forces accountability. When you publicly acknowledge a problem as a mishap or high-visibility close call, it triggers formal investigation procedures. You can't just sweep it under the rug and hope nobody notices. But NASA waited and hedged and minimized until they finally had to admit the crew couldn't come home for 9 months instead of the planned 2 weeks. Think about what that tells you about institutional priorities. Protecting the program's image became more important than protecting the crew. And that's exactly the mindset that leads to disasters. Here's the irony that nobody seems to talk about. NASA already knows how to do this right. We have proof. It's called Crew Dragon. When SpaceX started developing their crew capsule, NASA didn't trust them. Why would they? SpaceX was this upstart private company run by a guy who made electric cars and wanted to colonize Mars. NASA put SpaceX through absolute hell. They demanded strict safety standards, exhaustive documentation, and constant verification. Every claim had to be backed by test data. Every system had to be proven in the harshest conditions NASA could simulate. And you know what happened? That brutal scrutiny made SpaceX better. Instead of slowing them down, the pressure forced SpaceX to refine their entire development process. They couldn't hide behind paperwork or theoretical models. They had to prove everything worked in reality. SpaceX adapted by creating what they call an iterative waterfall approach. Traditional NASA methodology follows classic waterfall development. Design everything perfectly on paper first. Document every single step. Get approvals at each gate, and only then start building and testing. It's methodical. It's safe. It's also incredibly slow and expensive. SpaceX combined that rigorous structure with their own culture of rapid iteration. Build something, test it, watch it fail, figure out why, fix it, test again. The key difference? They proved systems through actual test data rather than theoretical documentation. Instead of spending months writing papers about how a docking mechanism should work in theory, they built dozens of prototypes and actually docked them hundreds of times under every condition they could think of. This wasn't reckless. It was the opposite. By failing early and often in controlled tests, SpaceX identified problems before they became disasters. Every explosion, every hard landing, every test that didn't go perfectly, those weren't failures, they were data points. Each one taught them something specific about what doesn't work. While NASA and Boeing were still arguing about paperwork for Starliner, SpaceX was already flying astronauts to the ISS successfully. Crew Dragon went through hundreds of real docking tests, countless reentry simulations, and aggressive failure mode analysis. When NASA finally certified it for crew flights, it had been proven in ways that Starliner never was. The results speak for themselves. Crew Dragon has flown multiple successful crewed missions. Starliner left astronauts stranded in space because nobody wanted to admit the thrusters might not work during re-entry. One spacecraft was tested to destruction and rebuilt stronger. The other was tested on paper and assumed to be fine. Now let me show you something that explains why SpaceX keeps winning this race. It's not just their testing methodology, it's something much simpler and more powerful. They never change their mind about where they're going. Since Elon Musk founded SpaceX in 2002, the company has had exactly one long-term goal: get humans to Mars. Every single project, every contract, every spacecraft they've built supports that singular vision. When they developed technology for NASA's Artemis program, orbital refueling systems, the ability to relight engines in deep space, long-duration life support, that's not just fulfilling a contract. That's building the exact capabilities they'll need for Mars missions. SpaceX isn't helping NASA get to the moon as their primary mission. They're using the moon program as a stepping stone toward Mars, and NASA is essentially paying them to develop Mars technology. That's strategic brilliance wrapped in contractual obligation. Meanwhile, what's been happening at NASA? Every administration changes space priorities like they're rearranging furniture. George W. Bush announced the Constellation program to return to the moon. Obama canceled it and redirected toward asteroid missions. Trump reversed course and pushed for moon landings again. Biden added Mars to the mix while keeping the moon focus. Each policy shift meant canceled missions, scrapped hardware, wasted years, and billions of dollars down the drain. You can't build a sustainable space program when the destination changes every 4 to 8 years. NASA's engineers aren't the problem. They're incredibly talented people stuck in a system that keeps resetting their work because political winds shift. Here's what really drives this home. If SpaceX succeeds in helping NASA land on the moon by 2028, they could realistically send the first humans to Mars around the same time frame, not because they're moving faster than NASA on any given project, but because they've been moving in one direction for 22 years straight, while NASA has been zigzagging based on whoever's in the White House. Which brings us to Trump's recent executive order. On the surface, it sounds great. America will return to the moon by 2028. Presidential commitment, national priority, historic achievement. But here's what the order actually does and doesn't do. Executive orders aren't laws. They're presidential directives that tell government agencies what to prioritize. They sound official and binding, but any future president can simply cancel them with a signature. Biden modified Trump's 2017 Moon Directive when he took office. The next president could do the same with this 2028 deadline. So NASA is being ordered to achieve something historic on a timeline that might not even survive the next election. Even worse, the order directly contradicts Trump's own budget proposal from May 2nd. That plan cuts NASA's funding by 24%, dropping it to about $18.8 billion for fiscal year 2026. It also aims to reduce NASA's workforce by nearly 1/3 through retirements and buyouts. Let me say that again. NASA is being told to move faster while losing 1/4 of their budget and 1/3 of their people. Nearly 300 current and former NASA employees were so alarmed by this that they signed an open letter. Their warning was blunt. These cuts are so severe that astronauts could die. When hundreds of insiders risk their careers to publicly break ranks and warn that people might die, you should probably listen. The math just doesn't work. You can't accelerate a program while slashing resources. It's like telling a construction crew to build a skyscraper twice as fast while firing a third of the workers and cutting their budget by 24%. Something has to give. And in aerospace, what gives is usually safety margins. This is where Elon Musk's solution becomes starkly clear against NASA's approach. SpaceX isn't waiting for perfect budgets or stable political wins. They're building Starship with their own money, testing it at their own pace, and learning from real flights out of Starbase. Every launch, whether it explodes spectacularly or achieves new milestones, advances their understanding of what works. Starship has already hit dozens of NASA's Artemis milestones for the human landing system, life support systems, power generation, docking mechanisms, fuel transfer capability. And it's doing this while still in what SpaceX calls the testing phase. By the time NASA is ready to actually send astronauts to the lunar surface, Starship will have flown so many test missions that it'll be one of the most flight-proven spacecraft in history. That's the solution NASA refuses to fully embrace. Not because they don't understand it, they literally forced SpaceX to prove it works with Crew Dragon. But because institutionally, NASA can't afford the optics of public failures. Every time a Starship test ends in an explosion, SpaceX learns something valuable. If a NASA rocket exploded during testing, Congress would hold hearings and threaten budget cuts. So NASA keeps flying with known issues: faulty power units, cracked heat shields, untested life support systems, because admitting they need more time and money would be politically catastrophic. They're trapped between impossible timelines, shrinking budgets, and a safety culture that's being eroded by schedule pressure. The real shock isn't that Elon Musk found a better solution. It's that NASA had the solution all along, proved it worked by forcing SpaceX to use it, and still won't apply those same standards to their own flagship program. NASA's flying astronauts with a broken heat shield. SpaceX proved there's a safer way, and NASA knows it works because they forced SpaceX to use it for Crew Dragon. The solution isn't revolutionary technology. It's simple. Test until you find every failure mode, fix them, then test again. NASA taught this to SpaceX, but won't apply it to Orion. The real question isn't whether NASA reaches the moon by 2028. It's whether they'll fix their safety culture before another crew pays the price. Should NASA ground Artemis 2 until the heat shield is proven safe? Comment below. Like and subscribe to New Space Review for space industry investigations nobody else will show you.